reservoir get warm. So it's pretty much a direct link. And then secondly, the reservoir is responsible for maintaining this wonderful cold water fishery that we have. So if anybody wants to take down the dam, good luck with that. Okay, secondly, we've done some riparian forest modeling. So this is what's happening within the floodplain. And this doesn't go for the full stretch, but pretty much focuses on the 23 kilometers just downstream of Anderson, where there's a little more floodplain area before it really gets canyoned out. And so what we did is we looked at 2016 as an average hydrologic year and 2017 as a really wet year. And then we also compared, what if we take an average year and then think about how can we use restoration planting, right? And so that assumes that you either have nursery stock of a cottonwood with about 50 centimeters of rootstock, or you can plant a whip about 50 centimeters deep. And that's the assumption. And then these are the hydrographs on the right. That horizontal dashed line is bankful flow, and so that's where water starts spilling onto the floodplain. Okay, again, a terrible figure. And so what we have are 3 cases for 3 different sites, right? And so A is the results of how do cottonwoods and willows recruit and survive in the first year of their life. For A, the average year, B, the wet year, and then C, if we use restoration planting for an average condition. And so on the upper left there, I don't think I have the laser pointer, but that's Cow Creek, and then Danskin Bridge, downstream of Danskin Bridge, and the upper right, and then at the bottom is just downstream of Reclamation Village. What we can see is that from average to wet, still pretty abysmal natural recruitment of riparian vegetation. However, there is a lot more riparian success if we do this restoration approach. And so fundamentally, we can predict where would restoration be successful within the floodplain. Okay, but some of our results say that pretty much greater than 99% of seedlings fail during average years. And that's principally because water doesn't go over bank and inundate much, right? That makes a lot of sense. But what was really disappointing is that in 2017, which is the highest water year we've seen in a long, long time, there was pretty abysmal recruitment success naturally. And so how could we bump that up? We don't necessarily know. Principally, it's because flow releases just weren't big enough. And there was no disturbance, right? And given what's in the watershed, we probably can't go much higher than 2017, otherwise people would start frowning. And so what we didn't understand is what are the mechanisms that led to this failure, right? What physically happened? Is it bad peak timing? Like, was it off? Was seed release versus flood? Inundation off? Was there simply not enough shear stress going on to create physical disturbance, whereby it cleaned out existing vegetation to create a bare nursery site? We just didn't know. And so we retooled our model, and now we can predict these failure maps. And so what we can see is that on average, almost on the average year in the upper right, as an example, red means all the parameters fail. So from a physical process standpoint, you are not going to have much success in the red, no matter what you do. Whereby, in terms of in the wet year, we can see about half of the floodplain is still pretty marginal for naturally recruiting, but half of it, with a little help from people, we could start restoring, and then the green would be natural success of these recruitment. And so what this allows us to do is, at an individual floodplain level, identify areas where A, passive restoration may work, or passive riparian recruitment and regeneration would occur versus where do you want to target for potential restoration, right? The yellow areas here are where you could just have manual crews go through and potentially disturb the sediments and or existing vegetation. And under the right flow conditions, you could have natural vegetation improvement. Whereby the red part, you have to do full floodplain reconstruction. Secondly, you can optimize sort of what you want to do for floodplain scale, right? Do you want to target deep planting? Do you want to increase the base flow in various areas? And what does that mean? And then this also allows for different flows. You could do this modeling in advance to understand what the next water year may be so that you can plan for that. So if you know in February that you're gonna have a really wet year, you can just look at your model results and send the people out to do the restoration, and then potentially we could have natural recruitment and or restoration. And then finally, you can compare different floodplain units, right? So where's the low-hanging fruit for restoration? What has the most potential area for helping out that vegetative recruitment? And then we have this suite of models. What would we like to do with it next? And one is establish the river habitat and its dependence on changing climatic conditions, right? What would happen if the distribution of water within the watershed changed, if it becomes drier, et cetera, and also what are the resultant reservoir conditions and how does that translate? We don't really have a 3D water quality model. There are some in place. I don't think they tell us what we need exactly. And I think there's an exciting opportunity with Cat Creek because they have one of the world's best reservoir modelers to potentially do something like that. I'm not going to go into that. And can we evaluate potential climate scenarios and how that translates through the reservoir and what is the impact on the river. Secondly, we can look at this riparian modeling and say, can we quantify forest biomass on the floodplain? And right now, I would argue that probably we don't have any idea what's out there, right? We can look at it and say, oh boy, this is really green. After the fire, we had this great response because everything shot back up and now we have more trees than we did before. But in terms of an actual number, we don't know. And so this would allow us, to further our model, we can estimate floodplain carbon volume, we can evaluate habitat availability for, say, yellow-billed cuckoo or any of these bird species, and then we can assess, hey, how do those vegetation changes in terms of long-term forest accounting. And then finally, we could understand how, if we wanted to pursue this restoration of riparian vegetation, how can we use some short flow pulses to help out these young riparian trees, right? Basically what we see is late in the season, all of these seedlings get desiccated because the water table drops. And could we use just a 1-day or 2-day flood pulse to really help out those when they're needed? We just don't know. These are all great science projects that we would like to pursue. We're just looking for a rich benefactor. All right, so that's kind of a rundown of what's available. And please hit me up with any questions that you have that come to mind. We have a couple of publications that I'm happy to send to you if you're interested. And yeah, we'd like to help see you make this project work out as best we can. Any questions? All right. Oh, yes.
Regarding the modeling, wondering if you have to have had tried to do a planting to then get those models of where it's not optimal to plant, that if you could do that without having tried to plant and it failed.
What do you mean, sorry? Have we tried planting?
Well, no. So where the plantings, where that restoration failed, and you figured out, and you can go back and figure out how it failed.
Yeah.
Can you create those models without having had tried to plant?
We did not try to plant, those are just simulated.
Oh, okay.
So that can tell you where you would want to plant.
Okay. I think that's even better.
Right?
Then we can-
We're trying to make it really easy for you.
That's awesome. Thank you.
You bet.
How frequently do you have to run the model to be able to rely on it year to year, do you think?
It's an excellent question. I don't think you would have to rerun the model at all. I think all you need to do is establish the flows. So right now we have flows from, I'm going to use metric here, but essentially 150 CFS to 200, I don't know, what's the maximum? What's 250 cubic meters per second?
8,000.
A little more than 8,000. And so we have a series of these flows. And so essentially what we could do is understand at each of those flows, what does it look like in the future? And then essentially the results are there. The only difference would be after 2000, this is based on the green LiDAR from 2007. It was an experimental LiDAR, and it does not have as good a quality as the red LiDAR does, but we don't know how the channel has changed, right? And so the bathymetry of the river we know has changed a little bit. There's some new bars, blah, 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 channels widened in places. That would be the one thing that affects it. And so we would probably have to figure out how to address that. Yes?
So is the purpose of the plantings to prevent erosion, or is it to provide shade for the water, for side channels and such?
All of the above, right? We know that riparian vegetation, I think we have to think holistically about river corridors, right? And I think we tend to think of rivers as static features, and they're not, right? They evolve over time, and so do the riparian vegetation. We know that large wood in the channels is beneficial. There are people of whom hate large wood in the channel for very good reasons, right? Flood control, et cetera, et cetera. But all of these, we need to figure out something that's acceptable in terms of what benefits carbon inputs to the channel, creates habitat dynamic erosion and pool scour, particularly in the main channel. I think it's basically a wide blasted channel, right? And at irrigation flows, if we have a little wood in there along the banks, there could be some dynamic habitat that builds in there as well.
Thank you.
Yeah.
And a follow-up then. So the thought or idea of water flow pulses during certain times, is that effectively then to water those plants?
That's great.
Okay.
Yeah.
That 99%
Yeah.
vegetation survival without failure, that seems like an overwhelming figure. Is that uncharacteristic in any way, or is that pretty standard or unique to this basin?
I would argue when you're out there fishing, how many young cottonwoods do you see? And not necessarily after the fire, right? Because a lot of those are root sprouts, and I would argue that almost all of those are root sprouts. And I would not say it's characteristic, right? What was really disappointing is the wet year. We know that cottonwoods don't do very well in average years in terms of reproduction, just because they require a huge flood pulse, right, to fundamentally fill their life history. But it wasn't big enough, right? Because there are no more gravel bars, and we have existing riparian vegetation that's super strong, we can't wash anything. Everything is super stabilized. It's like an ossified landform. And so I think that's what led to that pretty poor failure. Also, I feel like the channel has downcut after the dam sediment supply has been cut off. And so all the sand and everything that dumps out in the upstream reservoir does not make it into the channel, right? And so now that's what makes it this great fishery, is we have all cobble and gravel downstream, but we basically see incision, and so flows that would historically have gone over bank now do not, right? So the channel can actually handle a larger flow. Yeah.
But didn't we have more sediment in the river post-fire?
We did. There were some debris flows, but if you think of the sheer magnitude of sediment coming in this basin, right, up from upstream, all of that has been cut off, right? And so we did see a nice flood pulse or sediment pulse, and those were the most beneficial for riparian recruitment. Islands changed and built, and bars changed. It was really kind of an exciting time to be out there from a geomorphic standpoint, but they're so limited, right? Like we saw this slug of sediment, and now it's pretty much gone. It's been washed down, and so would you think about putting more sediment in there? Probably not, but like upstream of the reservoir, you see that huge peninsular delta that's forming, and all of that historically went through. And so, yeah, it's not as dynamic as we thought. All right, thanks guys.
Thanks. Yeah, sorry for jumping straight to the science before our coffee break, but Andy has to meet some other scheduling requirements, so I had him go first so he could fit all of that other stuff in.
Anthony, if people wanted copies of the presentations, could they contact you, or are you going to post them somewhere?
I started the recording, but it's a little late. So the beginning of mine, the actual speaking won't be there, but there will be a recording attached to the invite. So if anybody is not on the invite, that wants access to it can reach out to me. The actual presentations, I'll have to confirm with the presenters, but I'm assuming that we will be able to send those out, if not post them to the website.
Okay. Are you gonna mention the website to folks? Okay, thanks.
Yes.
Okay, hello, I'm Kira Cusack, I'm with the Fish and Wildlife Service, and I actually just started my position pretty recently there. I used to be with the Forest Service, but excited to work with y'all today and work through this project. And basically with the Fish and Wildlife Service, we're responsible for helping to recover a listed species. So I just wanted to briefly go over the listed species that could occur within this watershed here. So, and just really quick, this is a little bit more working with federal actions oriented here, but part of the Endangered Species Act is we do interagency cooperation with other federal agencies. And so part of that is federal agencies also have a responsibility, so other federal agencies, not including the Fish and Wildlife Service, only have responsibilities to help carry out programs that help to also recover these species. And then federal agencies also consult with the Fish and Wildlife Service to ensure that they're not jeopardizing the continued existence of these species. And sometimes there's also benefits to these projects. In this case, hopefully that would be. So preliminary potential species. And this doesn't necessarily mean that we may affect these particular species. It would all depend on what ends up being proposed and where projects would occur. But potentially these are the species you might see on this list. And people can get a species list through the IPAC, which is the Information for Planning and Consultation. And you basically just draw out your project area in there, and then it'll give you a list of species that may occur within that area. And the action area is kind of the area that you would analyze, and that's the area that is affected either directly or indirectly by our federal action. So you can think of, you know, a project might occur here, but some of those actions might flow downstream and affect an area further away than just where it's occurring. So some of the species that might occur are the Canada lynx, which is a threatened species, North American wolverine, which is proposed threatened, monarch butterfly, which is a candidate species, whitebark pine, which is threatened, and then bull trout, which is also threatened. And then for critical habitats, we just have bull trout critical habitat in the area, and I'll kind of go over each one of these. So Canada lynx, there's the Trinity Lynx Analysis Unit, which is kind of where you kind of analyze that species. Really no recent detections anywhere in that area. And as far as updates for that species, there's a draft recovery plan in progress. So no real other updates on that one. And for North American wolverine, there's potential for that species to occur within the action area, depending on the project scale, how broad it is and where we do activities there. And this one has a few more updates going on. The species status assessment addendum was completed September 28th, 2023. So just recently, and then there's a listing decision on the North American wolverine that may come out hopefully in November of this year. Right now it's proposed threatened, and so there could be a change in that listing at this point. I'm not sure what that would be. And then the monarch butterfly, which is a candidate species, it has potential to occur within that action area as well, and it's really dependent on milkweed. I know milkweed is in that corridor, so you know, I would definitely consider that species with whatever work's being done. And they're working through that species. There might have a proposed listing or critical habitat to kind of work towards that in 2024. And then there are conservation recommendations for projects for this species to help with their, help them along. Then white bark pine, potential to occur within this watershed as well. It could be in the action area depending on the project scale. Again, it's more of a high elevation species. And then species updates, it was just recently listed this year in January as threatened. And then bull trout. So bull trout we definitely have, as been discussed. It's throughout the South Fork Boise River there. And then for tributaries, definitely Rattlesnake Creek. And but really, if they have access and there's adequate habitat and supportive stream temperatures, potentially could be occupied in there for the tributaries. And as far as critical habitat, we have the South Fork Boise River, that entire reach there, and it's designated as foraging, migratory, and overwintering habitat. And then you have Rattlesnake Creek, which is designated as spawning and rearing habitat for bull trout, entire reach. And then Little Rattlesnake Creek, as Anthony said, it can go dry, and it's designated as critical habitat, but not it's not really designated as either one of those. It's just critical habitat. And for species updates for bull trout, they are working on the species status assessment. And it's in progress. It's pretty far along at this point. And then critical habitat. So these are the physical and biological features that are kind of important to critical habitat for bull trout. So just something that to keep in mind for any work that's being done in critical habitat to make sure we maintain these things. So spring seeps, groundwater sources, those are all really important for habitat and also helping to maintain low water temperatures. And then migratory habitats with minimal barriers. So it's great to not have culvert barriers, things like that. The waterfalls are obviously, we probably are going to be addressing those. An abundant food base, and then complex. I shortened some of these because some of them were kind of long, but I left number 4 as it was because I thought that was kind of a good applicable one in this case. Complex habitat for them. It's great to have large woods, side channels, pools, undercut banks, and substrates to provide different habitats in there for them. They like that complexity. And then water temperatures, as we know, bull trout prefer lower water temperatures, so that's an important one too. Some of those tributaries would definitely be temperature limited for them. And then substrates of sufficient size, that's especially important in your spawning habitat, which Rattlesnake Creek would be there, and just making sure there's not a lot of fine sediments is important. And then natural hydrograph, obviously in this case there's a dam, so that changes things a bit, but trying to mimic a natural hydrograph is beneficial. And then sufficient water quality and quantity that's supportive of bull trout. And so that would include, contaminants, in this case, sediment from additional sediment coming in from just where people are creating disturbances along the stream. I know we were talking about sediment limitations, but that was something that's concerning when you have all those disturbances along there and loss of riparian habitat. And then fewer no non-native predatory species present. Then other species to consider, yellow-billed cuckoo is threatened. It did show up on my list, but I would definitely consider this species. They're a riparian. They use riparian areas. They're like the cottonwood galleries. And there has been some detections in that area in the past, and they could definitely use this area as holdover habitat. So that'd be a good one to consider as well. And then, of course, bald and golden eagles, migratory birds, and then just native species in general, because they're all kind of interdependent with our listed species. There's my contact information, and if anyone has questions on anything. Yeah.
Your last point on the previous slide of the slide prior, few or no non-native predatory species. Can you outline a little bit more of what critical habitat, what are the guardrails and sort of dividing lines between places like the reservoirs that have relative abundance of these non-native species, some of which could be warm water, and how they're sort of divided between critical habitat of Rattlesnake Creek, and how that is separated from the reservoirs
Right.
where there's very different user groups.
Yeah, and that's kind of the hard part to manage around at times is, and fishing game is around that as well. And it's just trying to, like brook trout is a big species that can compete with bull trout. So that's one of the big species that we concern about, not necessarily predatory in that sense, but kind of more thinking in non-native species that aren't necessarily predatory but might compete with that fish is also an important aspect. But in reservoirs, it's a little difficult because there's important fisheries going on. So it's just kind of balancing that, making sure that whatever's going on isn't going to jeopardize that species, that we're still able to maintain a bull trout population. So does that help?
I gave you a terrible question.
Okay, it's one of the hardships of managing. We're definitely just trying to keep it in balance as best we can.
Yeah, so all of this information will be very important because a majority of the basin is federally owned. And if we're not on federal land, then we are probably going to be using federal money, which makes consultation for the Endangered Species Act a thing that we're probably gonna have to do for most, if not all, of the potential projects in the area.
And how that would occur, whoever's the lead agency or would consult with the Fish and Wildlife Service on all the projects, and then that agency would come up with their determinations on each species, and then we go through that consultation process with them.
One time for each one.
Just one consultation for all species. And some of them might be a no effect, others might be an adverse effect, so you can just do one consultation for all of those species.
Yeah, so we could bundle projects together for consultation, we could have individual projects. That's kind of one of the things that we'll need to figure out as we move through is with my understanding, limited staff availability for doing NEPA and ESA consultations, we may need to figure out ways to improve the efficiencies of the federal consultation process so that we can bundle things or make it easier for them in every way possible to be able to meet these requirements while still getting work done. All right.
Thank you.
Thank you.
Let's do a 15-minute break to get some coffee and snacks from the break room across the hall. Use the restroom facilities, which are down the hall. Come back at 10:33.
Yeah, but they should.
All right, did everybody get to sign in that is willing to sign in on the sign-in sheets? All right, well, folks are continuing to sign in. Has anyone snuck in behind me that didn't get to do introductions this morning when we went around? All right. Tim is with Fish and Game and was just out on the river this week, so he's going to give us an update and a history of what is going on with the fishery.
Yeah, thanks for that. So I'll go through, this is kind of a typical presentation I give about South Fork. There's going to be some kind of historic stuff, a little background, site description, historic context. I'll talk about our monitoring efforts, both past and present, talk about some results and discussion about that. I will be completely honest, I don't have anything to say about being on the river yesterday. I'm still drying out, so there's not any like hot off the press information. There's still fish in the river, so I hope that's about us, and they're nice fish. So yeah, I haven't had the time to do any of the pop estimates or anything from that. So we've gone through this. Some of this is going to be, we're all talking about the South Fork Boise Watershed. So some of this is just going to be kind of repetition. Here's the site map, right? You've got Anderson Ranch Reservoir here in yellow, Arrow Rock in that kind of whitish gray, and then Lucky Peak downstream. And the blue line obviously is the South Fork Boise. We're all familiar with it. It's a robust fishery. You have obviously rainbow trout, you have bull trout, and then we have some native species. We've got some sculpin, whitefish, some sucker species. We have some non-native game species as well in the basin. Kokanee is another one of the kind of, within the basin, I would say the South Fork Basin, not necessarily within the confines of this watershed, but we saw 2 kokanee yesterday, or Tuesday, they're up spawning. So there are kokanee that move up, either up out of Arrow Rock or down from Anderson, whether it's volitionally or not. So Anderson Ranch Dam, obviously that's the headwater, or the start of where we're talking about. That's the upstream terminus of my purview. So Anderson Ranch Reservoir is not my jurisdiction. From the dam down is where I start. It was built in between 1941 and 1950. It's 456 feet tall. At the time that it was built, it was one of the largest dams in the world of its kind in the world. It's a hypolimitic release, so that means it's a cold water release from the bottom. That's what provides this cold water trout, tailwater fishery. We've talked about some of these regulations a little bit. Anthony mentioned it previously. This is kind of how it broke down. So from 1977 to 1980, the regulation structure was 3 trout. They had to be greater than 12 inches. 1981, that shifted an inch. They had 3 trout greater than 13 inches. From 1982 to 1991, there was kind of a little bit different regulation structure there. There's 3 trout. It'd be greater than 12 inches, and one had to be, less than 12 inches, and one had to be greater than or equal to 20 inches. From 92 to 2001, there was a slot limit between 12 and 20 inches, and the bag limit was reduced to 2. From 2002 to now, it's 2 trout, 20 inches or greater. There's also a seasonal closure. I'm sure most of them, if not all of you, are intimately familiar with this, that began in 2011. It's a seasonal closure that starts on April 1st, and it goes to the Saturday, essentially the Saturday before Memorial Day. There are only 3 rivers in the state of Idaho that have a similar regulation structure to the South Fork Boise. It's pretty much, I would say, compared to our other fisheries, especially in the region and statewide. For a resident fishery, it has some of the most restrictive regulation structure compared to, our general southwest region is 6 trout. Some other places, there's also some, there's deer restrictions on other places. So the South Fork has a very long history of regulations, and it's shifted throughout time. And currently, as we say, we have some relatively restrictive regulations compared to other places in the state. Talking about stocking, so Anthony kind of mentioned this. The South Fork has not been stocked since 1976. Prior to that, it was receiving about 15,000 rainbow trout per year. The stocking in the basin, however, does contribute to the reservoir a little bit. So Arrow Rock receives about 10,000 kokanee annually and about 15,000 rainbow trout. Anderson receives about 150,000 kokanee and varying levels of rainbow trout. And like I mentioned, there are, like, in particular kokanee, that's another species that I work on quite heavily. We do see entrainment from the upstream reservoirs downstream, and then we also see fish moving from the downstream reservoirs upstream. There's been a bit of research. I'm sure that I'm forgetting some publications, but these are two I want to highlight. This paper that's talking about Mixobolus ceravolis, that is whirling disease. So there has been a whirling disease paper published out of the South Fork. The South Fork is whirling disease positive. And then this one on the bottom that was done by Helen Neville and Jason Dunham. This is a genetics paper. The take-home message, and both of these you can find them on, Google Scholar or what have you. They're pretty easy to find. The take-home is that most of these rainbow trout in the South Fork are genetically impure. They're kind of a mixture of a number of different rainbows, kind of Oncorhynchus species. They're kind of a coastal. They're not a genetically like interior red band. They're not genetically pure in that way. So in terms of the surveys that we've been conducting, there have been periodic creel surveys conducted since the early 2000s. In the early 2010s, there were some tributary surveys. I'll talk about that a little bit later. In 2012, we did some raft electrofishing. And from 2012 to 2016, we did fall fry sampling. And then from 2013 to 2015, we also conducted spring H1 estimates. And then the big one, which is what I was doing earlier this week, I'll be doing it again next week, are these triennial population estimates. And so what that means is they're conducted on a 3-year rotation. So 2023, 2020, 2017. There is a little weird thing in there, and I'll go into it a bit because of those large complex fires that occurred in the mid-2010s. This is the survey methods. This is a slightly outdated photo. We've gotten much safer. We no longer use a metal canoe. We use inflatable canoe. So what's happening is, and this is essentially from my perspective. So I'm holding the back of the boat. This box here is what controls our output, our electrical output. This is electrofishing. It's a very standardized, well-used, well-studied survey method for especially large river surveys. And then you can kind of see off of these floats, you can see this splash here. So there are 3 probes essentially that are thrown into water. You have to complete an electrical circuit. I'm not going to go into like theories of electromagnetism. There's a positive end and a negative end, like a battery. So the positive end are these probes that come out, throw these into the water. The negative end is the metal canoe. And so it creates an electromagnetic field. It causes involuntary muscle contractions leading to capture. So it's very similar to getting tased. Once the taser's off, you recover very quickly, especially if you're put into this this trash can here that has oxygen. You can kind of see these green cords flowing into there. That's got compressed oxygen in it. It's a recovery bucket. When we sample these fish, we capture them. Then once we get kind of a bundle of fish, we will weigh them, measure them, and then what we do for these population estimates is that we mark them. We use just a good old-fashioned hole puncher. We'll mark the tail fin, either the upper or the lower lobe of the tail fin. It's very similar to getting your ears pierced. And then we will go back, and so we know that essentially the way, and I'm not going to get into the mathematics. I know that you just had coffee, but it's still far too early for this. But essentially the mathematics is such that it's the ratio of marked fish that we put out compared to the number that we caught the second go around that are marked versus unmarked. And that's how we generate the population estimate. There's a little bit of math a little bit later in this presentation. I'm going to try and smooth it over for most everybody and make it digestible, because I know that this is not a professional conference. This is not a scientific symposium. This is a watershed group, and there's a number of different, I want this accessible to everybody in this room. So where we survey these sites, this is the same map. Really, the only thing that's changed is this canyon reach. We do not conduct these large river triennial population surveys in the canyon. The black dots now show the upper and lower boundaries of the survey reaches. So we have one right here that starts at Recreation Village, and goes down to that first campsite. There's like a big flat there that's 2 to 4 feet deep, laminar flow. Then we have another section right down here that goes, there's a small rock garden, and then it ends at pretty much Cow Creek Bridge. We affectionately call it the swimming hole, and among other things that I probably shouldn't say on a recorded presentation. But a lot of people go for swims. It's very swift, very slippery, and it's pretty difficult. And then there you have this third section that's downstream of the bridge that goes to that first campsite downstream of the bridge. That's that braided section, so there's a lot of different braids, kind of smaller channels, and so those are the 3 sections that we complete on this 3-year rotation. And so these are the population estimates pre-fire, and these are there's going to be some math associated with it, with a bit of these later, but this is, generally speaking, these are that very pure ratio of marked fish to recaptured and marked fish. And so what we're seeing between 2006 and 2012 is kind of a steady increase. And so these black points are the population estimate, and then these error bars are confidence intervals surrounding that estimate. So as you can see, we're kind of on an upward trajectory. Then obviously we've talked about this. There were these large, there's the Pony Elk fire in 2013, and then the subsequent debris flows, these are just a series of photos that kind of are post-fire. And so we've kind of shown a few of these, but these are just the ones that I've had kind of sitting in our fisheries photos drive. And so you can see that some of these are, they did deposit a lot of sediment. Obviously there's large scale debris flows post-fire. And so you can kind of see the different, there's different, this is Pierce Creek in 2014. And so now I've just put the locations of these debris flows within the roaded section as these little lightning bolts. So you can see, obviously there's the 2 here upstream of the village, and then these 2 kind of bookend our mark recapture survey sites, and then obviously there's this one right before the canyon starts. And so this is just kind of to familiarize everybody to where these were relative to our survey sites. One thing that occurred during this debris flow time is obviously with a lot of this fine sediment post-fire that was deposited, right? We've talked a little bit about sediment, and there's kind of a distinction I want to make there. Some sediment is great for fish, right? If you've got spawning substrate that, that kind of small cobbly stuff that fish can build redds in, that's great for fish. Very fine kind of ash flow sediment is typically not good for aquatic organisms. The point I'm trying to make, this is from the old temperature gauge at the Neal Bridge. So this is mean daily temperature in Celsius on the on the y-axis, and then year on the x-axis. And then what I'm trying to highlight here is around the time of those debris flows, we saw some of the highest recorded stream temperatures getting almost up to, almost 20 degrees Celsius in some of these places post. And that's most likely due to that increased fine sediment load that would increase temperatures. So this is now including post-fire. So we've got, 2010 here, 2015. That's why I'm saying there's kind of a little bit of not exactly every 3 years there, because this was 2013, and then 2015 is when we did the next round of these. And so you kind of see there's a, that post-fire, post-debris flow survey. It's kind of on par with the previous survey. The point estimate is similar and the confidence boundaries overlap. And then post-fire, you see this increase. Obviously that, what we're thinking this is probably attributed to is increase in spawning, so, more available habitat, whether that's substrate habitat, what have you. And then I do want to say, like in 2020, obviously we've got this little point down here. And so everybody's going to hammer on this. I've given this presentation a number of times, and I recognize that it's a shocking thing. Don't focus on this. I'll talk about why this seems very shocking, and there is probably an explanation for this. So now these are length frequency histograms, and what I'm talking about is frequency is going to be on the y-axis, so that's the number of fish we captured. Length is going to be on the x-axis, and this is in millimeters. The exact numbers, so the millimeters versus inches. So 420 millimeters is about 16 inches, 500 is about 18 inches, just to give some kind of perspective. And the thing that's kind of interesting is as you go through time, so we've got 2006 on the top panel, I guess. and then going chronologically down the page, is what you can see is there's these kind of two humps in here, and it's called a bimodal distribution. There's two kind of size classes. Those can also be attributed to age classes, but in 2009, 2012, 2014, and 2017, we see a lot of these kind of younger, smaller fish. And I'll say younger fish, I'll get to that on the next slide. And one thing that you don't see is this kind of, that hump in this smaller size class. One, I should have said this earlier with the electrofishing slide, one kind of central tenet with electrofishing is that typically larger fish are easier to capture because they have larger surface area that the electromagnetic field can act upon. So, and furthermore, these surveys are not, these big river surveys are not typically geared towards juvenile fish because we're, as you can see, you know, we have the 3 probes and we try to get kind of adequate coverage perpendicular to the flow. But the real shallow, like fry habitat that you typically, that fry and juvenile fish are typically associated with, doesn't get adequately surveyed with this survey method. We have other survey methods that we use to target juvenile fish. But we do see, which was very encouraging, is this large cohort of fish between kind of the typical, what everybody goes to the South Fork for, cookie cutter fish between 16 and 18 inches that are shaped like a football and pull like a freight train. And so, if you're asking yourself, how old is that, you know, cookie cutter fish? So now this is called a von Berlampi age and growth diagram from von Berlampi curve. And so what this is we take an age structure. So there's a number of different ways that you can age fish. There are lethal methods and sublethal methods. These were taken from sublethal method, excuse me, which is just you can section a fin ray, or the lethal method is an otolith, which is an inner ear bone. It's a calcified structure, and these aging structures, these hard structures, put on rings similar to a tree. So you essentially chop off a fin or peel open the skull cavity and pull out these aging structures. You section them under a jeweling, or section them with a jeweling saw, and then count the number of rings on with a microscope. And so that's how we generate these length at age, or von Berlampi curves. So now we have age on the x-axis and total length on the y-axis. And so 400-ish millimeter fish, so about a 16-inch fish, is about 4 years old. And you start getting, you know, greater than 16 inches, you know, you start getting into these upper age classes. This curve is as you can see, it's a nonlinear curve. Essentially, this theorizes the maximum length and age that a fish in the South Fork based off of this data set. So it's just based off of the available data. This theorizes the maximum length and size of, or maximum length and age of a rainbow trout based off of this 2014 data set. And you can see, you know, almost 600 millimeter rainbow trout, which is almost 24 inches, is 8 years old. And so if you kind of correlate these with some of these debris flows, we'll see year class patterns. And another thing that's kind of interesting that we can use with this data is modeled capture efficiency versus length. And so like I said, larger fish typically are more susceptible to capture with this survey method. So the vertical bars now are the actual capture efficiency. So this is just based off of that ratio of exactly how many fish we caught in these individual length bins. And then the black points are the modeled capture efficiency. And so what we can see is this population estimate, which takes into account capture efficiency, overestimating or underestimating certain size classes, and thus influencing that population estimate. So if you're overestimating your ability to catch small fish or underestimating your ability to catch larger fish, that's going to artificially bias your population estimate. So in 2014, you can kind of see, I mean, it's very rough, but you can kind of see on the modeled capture efficiency and the real capture efficiency, or the actual capture efficiency in the bars, both of those kind of follow this general increasing trend, right? There's obviously some gaps there where we didn't capture fish in those length categories, so you can't have actual capture efficiency for fish you didn't actually capture. But you can model that based off of this equation that you're deriving. In 2017, you can kind of see it's the modeled and actual capture efficiency likely, pretty closely follow. You can see like for this one, the model under predicted our capture efficiency versus what we saw, and then conversely at this 400 millimeter length bin, it's the opposite. And then the interesting thing, so harking back to this 2020, is that we really didn't capture fish less than about 270 millimeters. You can see that on this plot. So now this is the 2020 length and capture efficiency plot. And so we're really completely missing this size category. And so that's likely influencing our population estimate. You have to, when you build these population estimates, you have to set a parameter of your minimum length cutoff. So those previous slides that I showed you have no minimum length cutoff. It's taking into account every fish that you captured, every fish that you recaptured, and the range of that data. So if you adjust this based off of now a new minimum length cutoff, because we're under predicting, or we are the model is over predicting capture efficiency for those small fish in 2020, then we see this different pattern. And knowing that we are not adequately sampling, or this sampling method is not adequately capturing small fish of about 200 millimeters, 250 millimeters. Now we see this different trend come into play. So prior to the fires and the subsequent debris flows, we have a relatively stable population. And this is not for the entire river. I want to make this clear. There's not an estimated 950 fish from Anderson Ranch Dam down to the canyon. This is for these unique sections. So this is an index of a population estimate. I should quantify that. We see this relatively stable population of, in these reaches, right? The numbers aren't necessarily important for these reaches. This is based off of a 3-kilometer estimate. This is relatively stable for these three. There are the confidence bounds kind of bounce around. There's a slightly wider or slightly tighter confidence interval surrounding these estimates. Post-fire, we see a decrease, which is understandable, right? We saw increased temperatures. We see a lot of water coming down, subsequent debris flows. You can understand that it's not necessarily that the population estimate has gone down. It's that those fish could end up in the canyon or in a reach that we didn't sample. So there's going to be some reshuffling of the deck post-fire. And then a few years after, we see a huge increase. This has been documented across a number of different large-scale wildfires in the West. There's been a lot of work with how those interact with aquatic ecosystems. I'll talk about that a little bit later. We see this huge increase, but huge confidence intervals as well, right? So the point estimate, while it's way up there, you can also look at the bounds around that and think, okay, it's somewhere, we are 95% confident that the estimate is somewhere between these bounds. But compared to some of these other ones, like the 2020, we are much more, the confidence interval is much tighter. Thus, there's more confidence in that point estimate. I know I'm seeing a few glazed looks. This is getting real nappy. I'm going to try and get away from this. But it is important because, it's a population estimate on a river that everybody, this is a constant question about, how's the South Fork fishing? And this is kind of the data set that we typically use to inform, not just when anglers call in, but, you saw the history of stocking, the history of regulations, and all of these sorts of things kind of amalgam into how we manage the South Fork. So wrapping up the discussion about the triennial population estimates, they decreased following the 2013 fires and the debris flows. It increased in 2017, which is probably, that's 3 years after these debris flows. Those fish are probably, a 4-year-old fish is about 400 millimeters, so a 3-year-old fish is slightly less than that. So that increase is likely attributed to the increase in additional spawning substrate that was deposited with those debris flows. And then the 2020 population estimate is slightly lower, which is likely influenced by these minimal recaptures of smaller fish that are not typically as susceptible for these sampling methods. So, like I said, there's been a lot of work done on wildfire, large-scale wildfire that, kind of reshapes these landscapes and how that affects aquatic ecosystems. So this, Bruce Riemann in 1997 worked on a drainage near the South Fork, found fish were present within 1 year post-fire, and then 1 to 3 years post-fire, the population approached pre-fire level. So that's kind of a similar thing that we saw with more temporal resolution than we had, that post-fire, directly after the fire, there's still fish, it's decreased, but then 1 to 3 years, it rebounds to at least that pre-fire level. Juveniles increased, and that recruitment may have benefited from that subsequent kind of debris flow. Also, they noted temporary declines in the abundance of particularly like those smaller size classes. This 2011 paper right here had similar findings to temporary population depression post-fire, but a rapid recovery. And this one as well, this landscape perspective is kind of I would say more of a meta-analysis that compared to like an individual case study. I guess before I move on from adult trout to juvenile trout, does anybody have any questions about that?
So going back to your 2017 to 2020 numbers, you attribute the decline in the numbers initially, the significant decline, to not capturing small fish, right? Have you considered the possibility that Snowmageddon has significantly changed that river and the spawning habitat?
Yeah, I mean, there's like, none of this occurs in a vacuum, I'll say, right? So yeah, we saw a bunch of debris flows and increased substrate post-fire. We also had, massive flows that can sometimes be beneficial, right? We heard about how cottonwood recruitment can benefit from these kind of large-scale runoff events. I won't say flood, but large-scale runoff events. And so, yes, the timing, magnitude, and duration of flow can affect juvenile trout abundance. And, you can have your entire year classes wiped out. You can also have, great spawning substrate kind of, and the interstitial spaces in between that spawning substrate can be cleaned out with these large flows. So yeah, you might hurt for a little bit, but it might be a net benefit into the future. So yeah, that's definitely something that we've kind of, talked about for sure, is that there are benefits and detriments of these, and not that we can, control Snowmageddon. If we could, we would have a lot of water all the time.
Sure, yeah. Yeah, and the potential then that the side channels have filled in also with larger substrate, larger cobble, so those aren't available.
Yeah.
Okay.
Okay, I'm gonna move into the fry surveys. I'm gonna preface this by saying this work was conducted in the mid 2010s. That predated me. Art was, I believe, in the region at that time, and so I'm gonna try and make my way through this. We have some take-home messages, but I am admittedly less familiar with this data set because I wasn't involved in acquiring this data set. So these are from this spring fry survey. So like I said, we did in the mid 2010s, we did a series of spring fry surveys and fall fry surveys, and trying to understand ultimately, kind of what drives this fry production, or I guess I take that back. Not necessarily trying to find the drivers behind fry production, but try to understand trends in these juvenile trout abundance estimates. So this is just a length frequency histogram. It's pretty generic, like these length frequency histograms are widely used, and so it's just length on the x-axis and frequency on the y-axis. And so, we're in these fry estimates, we're seeing fish between, the range is from about 30 millimeters to about 120 millimeters is the range. And so that's what we're typically seeing when we're talking about fry surveys. And this is conducted in the spring. And so another way that we can look at this is river mileage. So we're starting, from the top down is how you would read this. So this would be higher up in the watershed compared to lower in the watershed, and then total length on the y-axis. And so there has been a linear regression line applied to this. There's a slight downward trend in that linear regression line. There's no confidence intervals applied to this either. And so, based off of a few fish, this could be adjusted one way or the other. So there is a slight, I guess the take home is that there is a slight decrease in size as you move down the watershed, downstream, if that makes sense. But really there's not a lot of, it's not like a very stark decrease in length as you move downstream. Excuse me. These are in the fall, so like this fish is like probably 4 months old or so, and so you do see this kind of shift in that size in the range of that size structure. The previous one was from about 30 to 120 was about the maximum of most of those individuals were between that range. Now that's kind of been shrunken, so most of those individuals are between 30 and 90 millimeters, with some fish that are slightly larger. So, and then additionally, this is the same chart as before, river mileage on the x-axis and total length on the y-axis. And same thing, it's a little bit stronger of linear, or the slope is a little bit stronger, I guess if that makes sense. But it still is, the range is not all that much between this, these upstream fish, if you want to consider it that way, and these downstream fish. I mean, it's kind of helpful to have 4 TV screens all linked together because it kind of puts a crosshatch right there. And you can see how there's not much difference there between that linear relationship. So now this is apparent overwinter survival. And so the way that this has been, and correct me if I'm wrong, this is essentially the ratio of fish that we caught in the fall versus in the spring. And then that's on the y-axis, and then river mileage is on the x-axis. And so there's a lot of, I promise I wouldn't go into the math again, there's a lot of math behind apparent survival, but suffice it to say, this is essentially the ratio of fish captured in the fall versus the spring. And as a function of the upstream to downstream, like I was talking about. And so there seems to be, based off of this linear relationship, higher apparent overwinter survival in the upstream sections compared to the downstream sections. And then these are the linear densities on the y-axis now, and this is fry per meter. And then this is through the years of these fry surveys. So starting in 1996, going through 2015, and this is lumped spring and fall. And then you also can't really see them, they don't quite show up on the screen well, but there are error bars associated with these estimates. So some of these, like 2009, you can kind of see the error bar extends all the way up to here, and then also overlaps 0. So there's a lot of variation in the number of fish that we caught in 2009. That's probably the best way that we can describe that. And so you can kind of see these trends over time. You see this depression in the kind of the 2013 to 2014 timeframe, and then a rebound in this 2015. Now this is the same y-axis, linear density, fry per meter, as versus river mileage. And so linear density increases. There's based off of this linear regression, linear fry densities increase as a function of river mileage. So upstream, you have fewer fish in a line. That makes no sense, but you kind of get what I'm saying, compared to downstream. And now this is parsed out. So prior to 2012 or 2013, excuse me, there were just 1 fry survey conducted, and now we've parsed the 2013, 14, 15, and 16 data into those component parts. Right? I said on that previous chart that was similar to this, that those were compiled based off of the spring and fall estimates. Now these are parsed out. And this is also how we're getting these apparent overwinter survival estimates. So in the spring of 2013 versus the fall of 2013, and then spring and fall of 2014. And these are the percentages of the fall versus the spring. So if that makes sense. So this bar right here, or I guess we'll start with 2012. This bar right here where this laser pointer is I guess that doesn't make sense. We'll go the other way. So this hatched bar is 15% of this filled in bar. And so that's, you kind of back calculate. That's an easier way for folks to understand it, is you kind of back calculate these. But you're back calculating this. So this is 57% of this estimate, and kind of so on and so forth. And so you do see some variation in these overwinter survival kind of proportions. And like I said, in fall of 2015, we see, you know, this kind of market increase compared to the spring of 2015. And then this is kind of the end of this data set. We did talk a little bit about fry surveys. Like I said previously, this work was conducted in the early 2010s. You probably can't read that in the back. This upper plot is from Rock Creek. These are just length frequency histograms like I've shown before. Most of these fish are, if you look at the scale bar, this is in millimeters. Most of these fish in Rock Creek, Cayuse, Meineke, and Cow Creek are all relatively small, right? That's about 40 to 80 millimeters are these kind of large modes here. And then Pierce Creek, these are just sample names. Pierce Creek 1, Pierce Creek 2, and Rock Creek 9. Similarly, right, you see kind of, you know, typically all of these fish are less than 200 millimeters, but they're larger than some of these other tributaries on the left-hand panel. Real busy table, but this is how that data set, or this is the tabular form of this data set. So you have the stream here, the site name, the temperature. So you can see some of these places are getting pretty warm. So Rock Creek here, 31.2 degrees Celsius. How many passes we conducted, the estimate based off of that. So some of these, like with one pass, you cannot generate an estimate. You're essentially doing a linear regression estimate. So the ones that have multiple passes are the ones that you can generate an estimate on. This is the confidence intervals, and these are for different size classes. So, you know, less than 100 millimeters, greater than 100 millimeters, and then the total compared to, you know, that are summed up. And so we've got the stream names here, the temperatures again, passes, and the estimates. So some of these, you know, you see like Pierce Creek, PC1 and PC2, the two sites there, the estimates are pretty low, 19 fish, 6 fish with, you know, the estimate, or excuse me, 22 and 9, we'll go to the totals here. And then this is based off of the fish per, this is a density estimate, fish per 100 meters squared. And that's typically how we report some of these fry densities. And so like some of these, right, 12.1 fish per 100 meters squared, 6, 8.7, and then you look at some of these other ones. Down here, you know, you're seeing estimates of 54, 91, 43. So some of these places have, you know, or almost an order of magnitude more fry compared to other ones. So I know I to take questions or comments. We can, I think that hopefully I didn't get us too far off timing, but yeah, I'm happy to take questions at this time. Perfect. Just enough math. Use everybody.
Thank you.
Yeah.
I monitoring for the last years or so, the fall to spring overwinter survival.
Okay.
BVFF and some of us worked with Oregon, and we actually, in catching fry and some small fish, did scale samplings, measured where it was on the river, the date, time, length, and sent that in. So I'm going to assume the scales, they could determine the age of the fish. Any thought of doing something like that?
Not necessarily. I mean, fry size is, I guess we kind of know how old those fish are, right? The scaling age, the aging the scales portion. We kind of documented that based off of this fry stuff. It seems like that overwinter survival of the first year is kind of a population bottleneck. And that's, that's not unique to the South Fork. That's probably, you can probably find a ton of places that overwinter survival of young fish is important in determining kind of later year classes. In terms of conducting more fry surveys, I'll be completely honest, yesterday and Tuesday, we caught a lot more juvenile fish than we've seen in previous surveys. And I don't think that it was because we were targeting different habitats than we usually do. So that's encouraging to see. We do have, some of that, like, with the 2020 data, and right, we've only marked fish. We have not done the recapture run. I have no idea. A lot of those estimates are based off of how many fish you can recapture. And like I said, small fish I realize I'm making a lot, it's like I'm on stand in like a Senate hearing, I'm making a lot of qualifying statements. But there's a lot that goes into these population estimates, and some of those small fish don't show up in the estimate, but it's encouraging to see that, knowing that they're there, even just, anecdotally encountering them that I don't remember seeing them in 2020.
Yeah, I know that on the Oahe, a lot of this, I believe, was put together after the population of the brown trouts and the reds were getting stocked and they seemed to be dropping, and we went in and put in the, don't tread on me, to see if they were increasing, and ideally, it's been determined that since that's been done,
yeah, so
the population has come back.
And I guess with that too, so being a predominantly rainbow trout fishery, I'm not terribly concerned about people walking on reds during the time that rainbow trout are spawning. It's like peak flows. People falling at 240 CFS yesterday. Like, you're definitely not walking around on reds at 2,400 CFS in the spring when rainbow trout are spawning. And so in terms of, I guess, kind of a population bottleneck, with a fall spawning fish at low flows in a flow regulated system like the Oahe, right, it's 20 CFS or whatever, and like, you can see them, you can walk through them in flip flops and stay dry. And so, Almost.
It was still cold yesterday.
It was probably pretty darn chilly. But, so, comparing and contrasting kind of two different life history characteristics. There's a question in the back. Oh,
Jim.
No, next question.
Oh, quick.
We didn't make it quick, we gotta keep on moving.
Jim, I'd like to interject just briefly. In 97, 98, we found whirling disease in the drainage. And I was the guy that started those fry estimates because we were concerned about whether or not the whirling disease was wiping out the young fish that was hypothesized in Montana and Colorado. And we found pretty good numbers into the fall. And Art and I then followed it up to look to see if they were coming through to the spring, because again, those young fish are the ones that are most affected by that disease. And again, we found pretty good numbers coming through, and then kind of serendipitously, we had that data lined up to be able to look after the fire and the sediment input. And again, you saw a lot of fish, a lot of small fish in the fall, even with the sediment, and fish making it through the spring. So that's where those came from originally. And again, you then followed that through, and we've had pretty stable numbers of juvenile young in the year fish. And again, answer to that prior question, the length frequency, for fish that size, you can pretty well pinpoint their age.
Yeah.
Those are young in the year into the fall, and then 1 year old, at least by definition, coming out the next spring.
When will this year's survey be?
Follow up too, real quick on why we're not doing further pride survival type stuff is, we did multiple years, we had to focus. We wanted to start focusing on the lower Boise River and trying to figure out, what things influence fry production here in the Boise River. And no matter what you do with, no matter how much fluctuation you see with the fall fry abundance and whatnot, it's always the same on the other end, with winter being that big bottleneck piece. And so it's not really, sure, you can find out some things, but it's not a real effective thing for like management. And we sort of have to, you know, separate things from gee whiz, good information to what's going to be effective for us to monitor true changes and contributions to the population, I guess, so.
Yeah, we can continue these conversations in the future, but we gotta move on now. One of the things that I, with my previous career, was very unfamiliar with is the work that NRCS does, and I think this is gonna be a great opportunity for a lot of us that are familiar with federal lands and actions there, but this brings in a little bit of the private lands ability and the different sources of funding for that as well.
Well, thanks everybody, thanks for having me. Really excited to see how many people are in this room and the variety of people in this room. I'm also happy to say this is the third watershed group that has formed out of the Water Smart grants that I've been participating in, so this is really fantastic. Don't usually see watershed groups form this many in such a short time. I think it's just since the fall this has happened, so it's pretty exciting for me as a water geek. So conservation supporting water, NRCS Idaho. Who we are. Sometimes I still am so surprised that nobody knows who we are or knows very little about who we are. We are the Natural Resources Conservation Service. We are an arm, if you will, of USDA. We were established in the 30s based off of the devastating Dust Bowl. And here's some pictures of what that looked like. We are voluntary, non-regulatory, except for things like NEPA, where we have to follow federal and state water quality rules, endangered species, things like that. We are not a regulatory agency. We just follow the other laws when doing our work. We offer technical and financial assistance to address resource concerns on private agricultural land, and I'll talk about what resource concerns are. And private ag land to NRCS means farms, ranches, rangeland, and forests, private forest land. A lot of people don't know that one either, that we work with their foresters. Where we are across the state, I'm in the state office. I'm part of the technical services team. And we have programs, public affairs, engineering, and our GIS experts. This map on the right is where we are. We have 17 teams, as we call them, across the state. So when thinking about things like DEQ's region, we have, I think, four field offices within one region, the Boise regional office, for example. And that's where our boots on the ground, if you will, our conservation planners and engineers are that would be working with the individual landowners that would be interested in implementing conservation practices on their land. So what are resource concerns? Our little acronyms, SWAPA, soil, water, air, plants, animals, and then we add energy and humans. We are part of the entire ecosystem. It is looking at it more holistically, just not the parts, because we are all integrated and we each affect each other. So this is just for water, the resource concerns that can be identified on the land regarding water. So field sediment, nutrient pathogen loss, transport of sediment to surface water, salt losses to water, source water depletion. So we're talking about water quality and water quantity that we address that. So how are SWAPA and HE resource concerns addressed? We have conservation practice standards for just about everything that you can, an issue that could be happening on the land. We have 58 of those practices and established ground truth standards. They are publicly available. for all kinds of things, nutrient management, well decommissioning, restoring habitats, wetland restoration. I mean, I could go on and on. So these are guidelines for planning, designing, installing, and the O&M of conservation practices. Basically the cradle to grave, if you will. Programs and initiatives are designed with suites of practices to best address. So all of these 58 practices, to kind of put it all together, is there's this, index of practices, but each of our programs or initiatives focus around a specific thing, whether it be wildlife corridor habitats, which is a new initiative we have, or source water protection, source water meaning drinking water, sources of drinking water, both surface and ground. There are practices that have been identified by agency experts that will contribute to the improvement of that resource concern. So kind of packaging them together, more a systematic approach than individual practices. Kind of there's no silver bullet, basically. And then how it works is, if a landowner or a group or water management entity like the canal companies, water users want to do something, our staff in the local office will come out and assess the land, assess the issue, and propose ways that the condition can be approved. Okay, just a little bit of what I'll call our little toolbox for water quality and quantity for this group. What is our role in water protection? That is water quality and quantity again. We assist private agricultural land owners to address the impacts from agriculture to water. Specifically, sediment, nutrient, and pathogens. It's just part and parcel of the issue. Agriculture is identified as a non-point source. When talking about EPA, DEQ, it's a non-point source, except for animal feeding operations would be considered a point source. So we want to reduce the impact of this on water, but first and foremost, for example, if the soil is leaving the property, if you will, because there is erosion, there is there's runoff, there is a great deal in eastern Idaho, it's very, very windy, the soil is being kicked up in the air, this is all leaving the land. This is the productivity of the land, because all of the good nutrients and everything that's being put on the land is leaving the land and ending up in the water or in the air, and then in the water. So we want to keep the soil there, keep the soil healthy. Soil health equals water, better water quality and quantity, because if there isn't compaction of the soil, the water is able to infiltrate through to the ground and recharge the aquifers below. So as I mentioned, more of a holistic approach. We have many, many programs, but actually David and I had this conversation a couple of months ago about, it's not, I think sometimes those of us that run programs get bogged down in trying to tell you about our programs and what all they do, and you probably don't really care about the nuts and bolts of it. It's more about, what do you want to do? What do you want to see? What is the change you want to see? For those of you that have been fishing in this watershed for 50 plus years, what did it once look like? What could it look like again? That's what we're talking about. How we can best address that through our programs that can help private agricultural producers, but also at a community level, at a watershed level. So first we would look to see how you want to improve it, what you want it to look like, just kind of talk about those ideas, and then work with our staff to identify the best program practices, initiatives to address that. It's a much better approach than trying to get into the weeds, although I will get a little bit into the weeds on some of them, just so that you know the breadth of what we have available. I will tell you, when I came on to the agency, water has been my career my whole life, except agriculture was just sort of this ancillary thing on the side. I wasn't fully deep in it. But when I came here and I saw all of the programs, and this is just barely scratching the surface, I was amazed at what is being done and our state conservationist jokes that we are the CIA of agriculture, because nobody really knows what we do. So for individual landowners, the Big Bang program for us is EQUIP, Environmental Quality Incentive Program. Under that program, we have initiatives this is where I sit, source water protection priority areas and the National Water Quality Initiative. What the significance of initiatives is, and there's other ones for like sage grouse, wildlife corridor habitats, I could go on. The idea here is that general EQUIP, the cost share is about 50%. But when we're talking about the initiatives, we're talking more like 90%. So it's incentivized, targeted efforts to have landowners participate in conservation. And then for watershed communities, again, I don't think many know this, is that we go beyond the farm. We don't just work with local farmers, ranchers, and private forest landowners. We work at the watershed scale, the community scale. We have watershed and flood prevention operations. I'll talk more about each of these a little bit. The Resource Conservation Partnership Program, RCPP. This group is kind of one of those perfect storms for RCPP, I think, because you have lots of partners coming together to address an issue. Water Smart, obviously we're all here for that, but NRCS is a component that pairs with the BOR side. And then we have our Conservation Innovation Grant. So we're really encouraging those out there are developing technologies that might improve irrigation water management or whatever it is, if they come up with GIS or sensoring technologies, things like that, that would help on ag, forest, and rangelands. Just so we have a little scale, just real quick. So we saw the South Fork Boise. This is the lower Boise. These are the maps I have, so this is what I use. But this is the lower Boise watershed, and this is the HOP 8 scale, just the scale of how many acres are within it. So then on the right, we're talking about the HOP 12. HOP 12 watersheds or sub-watersheds are anywhere from 10,000 to 40,000 acres. So these 5 watersheds on the right sit within that lower Boise watershed on the left. Just for scale, because most of what we do, at least on the water side in NRCS, we operate at this HOP 12 scale. The idea being that it's a little bit more manageable. You can see some water quality improvement on this scale versus on that HOP 8. It's pretty big. So regarding the source water priority areas, I updated this with input from our partners. We do have a water subcommittee at NRCS that I oversee that. Basically, it's just a gathering of partners, get input on some of the things that we're doing. So this was dramatically increased. We only had 4.5% of the state's land mass covered by source water priority areas, and now there's the maximum allowed is 20% without a waiver as far as the agency is concerned. But it was an easy, I would say a relatively easy thing to do for me, because when you look at what the state has done, DEQ and IDWR, water resources, they've already identified and delineated areas of concern where there is water quality and water quantity issues. So those to me were just kind of the no-brainers. These are areas where we want to do a little more. How can we, NRCS, put that incentive on these watersheds to get conservation going, to reduce nitrates in the water. So these nitrate priority areas, these are areas around the state that have been identified to be unsafe. There are wells tested around the state that it's unsafe to drink, private and public wells. Public water gets treated, private only does if you decide to treat it. And so levels over what is deemed safe by the State Drinking Water Act. So identify those areas, and then the groundwater management areas are those where there is water quantity, water depletion, where it's not getting recharged. So the water's getting pulled out and not getting pulled back in. So that was easy. So now this is the 20% maximum. We can go over that with a waiver. I haven't gone that far yet. But what we realized too is it's not just the public water system. Wells are as well, because Just because you have a public water system doesn't mean that private well down the road isn't pulling from the same aquifer. So generally the same water, it's just one's getting treated, the other is not. I do have an interactive map for this that you can zoom in and out on those watersheds. I'm not going to try because Anthony already tried and it didn't work, so we can make this available and you can play with it. But you can zoom in and click on the watersheds and see the names, and it drills down really well so you can see your roads and towns and stuff, so you can kind of orient yourself where you are. Our GIS guy built that for us. National Water Quality Initiative, again, this is a targeted watershed effort designed for really a watershed where there is a demonstrable amount of interest of private landowners that want to participate in the program, whereas the source water protection area really doesn't require that. You could, as an individual landowner, participate without needing to have lots of other people in your watershed do that. There's 2 phases here. Basically, the ultimate goal here is that a Track 12 implementation plan for improving the watershed is developed in the planning phase, and once that gets submitted to our headquarters in DC, it's approved, you move into implementation phase. What that then means is that the landowners in these, and this is one example that we have, these watersheds, that initiative cost share rate is available then to those landowners, and the suite of practices is quite large. There's over 40 practices, core practices we call them, and then I think 50 some supporting, whereas in the source water priority areas, it's a little bit more targeted, fewer practices available, and this is the difference here. There's no limit to how many of these water quality initiative watersheds we can have in the state, and whereas the source water protection is a little more limited, but there are areas where it's going to be very difficult to get that level of interest from landowners. A lot of Idaho is federally owned, so you're not going to have that opportunity in a lot of watersheds. So that's kind of different. So RCPP, basically, it's kind of what's happening here. It's promoting partnerships. So say you have a canal company, you have a city, and you have, I think there was an example of this. There's a watershed group, whether it's Trout Unlimited or Nature Conservancy, all want to come together to improve an area, reach common goals, things like that on a regional scale. I don't have all the details because this is not my program, but we have a person that is dedicated to it, so if you want more information. There was outreach done by the agency on RCGP, and a lot of feedback came from the public and partners, and the program was heavily streamlined. So there's a lot less red tape. I don't know, I think they may have removed the matching. Don't quote me on that, but I feel like that's the case. So one example we have here, I'm sorry, I should not have put this much text on the slide. I try very hard not to do that. One example we have, there's lots of links here to this more information, but examples of these projects. So a lot of people are like, well, we want to do something. Well, what do you mean? What could we do? So the agency has put together lots and lots of examples of funded projects, so that you can try to get an idea of what that means. What do you mean? Trying to have those, dare I call them shovel-ready projects, things that you want to do. There's some examples here. So this one, the funding, the award given for this was almost $8 million. This is huge. This is a big one. This is not kind of typical. This runs across 3 states, Utah, Idaho, Wyoming. And it's for the Bear River Watershed Ag and Habitat Connectivity. So generally it's conservation easements, land management, to connect terrestrial, riparian, and aquatic habitats. And that's a lot of what we're talking about here is, water and aquatic habitat. Obviously, aquatic habitat is water, and water quality is aquatic habitat. Without good water quality, without riparian forest buffers, vegetated riparian areas, you're going to have increased water temperatures, more poor water quality. So that's just an example of that. Our flood program, our flood and watershed prevention program, there's kind of a lot of elements to this. There's a rehab portion of this, but this one used to be pretty limited to flood prevention, really involved with agricultural lands, but it has expanded like many of our programs through the 2018 Farm Bill, expanded much more into watershed protection, public recreation, fish and wildlife habitat. So really kind of, again, that more holistic watershed look. These projects need to be publicly sponsored. So say by a city, for example, and I do have an example. I do sit on those projects right now. These are for watershed projects that are less than or equal to 250,000 acres, so pretty substantial projects. There needs to be an ag benefit, but also a benefit to the rural communities for these. So currently we have 3 of these watershed projects, or we call them PO 566. It's just the public law, how we call them, that are currently funded, that they're in the planning phase. They have all had environmental assessments done. We are submitting them to the National Water Management Center for review. The first 2, North Cache Valley, runs over the border into Utah, and then Raft River. These 2 do not incorporate a community. They are more irrigation, water delivery projects, canal repairs, things like that. But then City of Cottonwood, that is an example of how we kind of go beyond private landowner, is that there is a great deal of flooding in the City of Cottonwood. If you've ever been there, they're just kind of down in a valley, and they're just like down in the bottom of a ridge, and the water's just going to come down on them. So there is a big project there as well. There is a wastewater treatment element for that one. We aren't funding that. USDA Rural Development has that part. So we also partner with our sister agencies within USDA, and with all of these, because they are federally funded projects, we have to do NEPA, or our version of NEPA. So we are consulting and cooperating with Fish and Wildlife Service, the state agencies, things like that. So where we do run over into lands that are managed with other federal state agencies, we are required to cooperate with them, inform them what's going on, have them, they have an opportunity to comment on the projects. And that is really high level. The link on here just takes you to NRCS in Idaho for more information. If you have any questions about any of this, even if I'm not the project lead, I can get you to the person that is in charge. Connor is here for the local field office. So for those of you who would want to work locally, he's the one, him or Connie Tharp is his supervisor. That's who you would contact locally. Thanks.
So we are almost on schedule. I got one quick question for you to clarify on my end of things. So if we have something where there's a specific small project that would be beneficial for multiple users. So let's pretend there isn't, thankfully, but let's pretend there's a diversion on the main stem river below the dam. And it's on private property. We want to screen it. We want to put offsite water in for cattle. Is that type of stuff, or do we need to fit in one of those big programs, or how would?
No, yeah, I mean, well, you need the landowner to be willing to participate in that, but absolutely, off-site watering is something, that is one thing we talk about with areas where there might be, where animals have access to surface water and that water quality isn't very good. There might be algal blooms, there might be something going on where it is not an ideal water source for the animal. So we're talking about more about animal health, not so much that. We can support that landowner by creating or establishing an off-site watering facility for the animal, and then doing some fencing to keep them out of that area for stream bank, stream bank health and stabilization, but also for ensuring that the animal is getting the best quality water it can get. So, but yes, all of that whole thing about what's your idea, what do you want to do? And then working with us to figure out how it best fits in what program or how. I mean, that's neither here nor there. I think to most people, it's just, this is what I'd like to do, however it is that we do that, you know, we all kind of come together and help figure that out.
Thanks.
Great, thank you.
All right, I think you guys are stuck with me talking again now. If I'm at the right spot in our wonderful agenda. So in the beginning, I talked about the reclamation program that's out there. There's also other sources of funding on the federal scale and the local scale for doing these different types of projects. So I mentioned that reclamation has their funding. There is additional funding from the Forest Service. We have a Trout Unlimited has a Keystone agreement with them nationwide that could be used for some of this stuff potentially. There's other funding from multiple different agencies. So I didn't want people to get confused that we have to go through reclamation to get any of the projects funded. It's just one of the options there that I started talking about at the beginning. So I've talked with many of you in the room and many people that are not in the room about different ways that the South Fork Boise could be improved. I'm going to go through some of those, give a few brief examples, and then we can open it up to see if there is anybody that I haven't been able to talk to that has additional ideas on top of that. But I do want to keep things at a high level. This is our kickoff meeting, so we're just getting to know what's going on and mostly getting those ideas out there so that we can discuss later on how we want to move forward to start addressing some of those potential opportunities. If you come up with anything, let's try to focus on the opportunity and not necessarily the issue. If you have an issue, you don't have any idea how to fix it, you're fine to bring that up. But I'm trying to stick to how we can improve things and not really dwell on what is wrong or could possibly be negative with the stuff that's out there right now. The biggest thing that I have heard from people involves some of the infrastructure that is there, the amount of use that is being seen in the system now kind of outweighs the existing infrastructure in some ways, whether that is boat ramps, bathrooms, campsites, parking, and a lot of that stuff. Instead of the actual fish, which we spent a lot of time talking about already this morning, there's not a whole lot of people complaining about not catching fish. It's when we go down there, there's now new rapids that are formed after the fires that make it difficult to use some stretches of river. There's issues with parking for camping overlapping with parking for boating, and sometimes not enough room for folks to fit in, and then they end up going to other places within the basin that are not official campsites or boat ramps. So this is, I believe, a user-made boat ramp and not a official boat ramp. This is a 121R road that is on the lower end of the roaded reach. People are using this as a boat ramp and backing in. There's some sediment issues associated with it. And also a unofficial fire ring to the right or the left right here that complicates parking for both uses at the same time, and also maybe bringing ash and other small particles into the river itself. Another major category that people have brought up is tributary habitat enhancement. So whether that is riparian plantings, beaver dam analogs, or managing the road or trail sediment that could be input at some of those crossings. We talked about a lot of the different tributaries earlier, and one in particular that has the extensive trail system on it is Willow Creek, that enters down in the pool of Ararock that is sometimes reservoir, sometimes river. Looking through Google Earth imagery, there's 26 different ATV crossings just on the main stem of Willow Creek. Some of those are probably not causing any issues, but there is the opportunity down there with that many crossings that we could do something to limit the amount of sediment that is being put into the creek and eventually downstream into the river reservoir by hardening surfaces or putting in bridges or working on something there. And again, these are just examples. There's no feasibility analysis of anything being done on what landowners or anything could possibly actually get put in. These are just ideas to think about as we think about how we're going to be able to decide what we can actually do moving into the future. Main stem habitat enhancement, we talked about things a little bit with Andy's presentation earlier. Riparian plantings versus manipulating the hydrograph to get natural reproduction. And then increasing side channels are different ideas. This is an image, I think this is actually, I can't remember which road it is. But off-channel habitats are very important to those juvenile fish. We talked about that earlier this morning. And if you look at the 1 meter imagery red LiDAR, even though we can't see into the stream channel itself, there are some of these areas where we've seen overbank flows at some point, and then all of that flow starts to combine and create these channels on the downstream end. And we may be able to reconnect some of those and make them connected not only at flood flows, but at the overwintering flow to expand that habitat out that Andy was saying has been compressed over the years. There's a lot of confusion on some of the regulations that are out there, talking to different folks. Not a whole lot of the fishing regulations except for is a treble hook, one hook, if you're limited to one hook. I've heard multiple different stories on what one hook actually is, and we can get into those details down the road. There's only one sign out there that I've been able to find that has the 14 out of 28 day camping restrictions. There's a lot of people that are suggesting that we install 14 out of 28 day camping restrictions like they have on the SNRA. So I think there's just a lot of education that could happen in some of these areas. And one of those areas is also publicizing things on our southforkboise.org website, which a lot of you were invited directly, but we have the invite and some summary information, and the agenda is all posted. There's a long history that Andy's done a lot of work on, and the local chapter's done a lot of work on. There's a lot of information there available on the website, and we are looking to improve that as well as part of the education and outreach portion of this group. So this is that sign you get, the bigger one coming down off the dam, and then in the campgrounds themselves, it only says 14-day limit, and a lot of people are interpreting that as I stay at one individual campsite for 14 days, then I can move to the campsite next door and stay for another 14 days. That seems to not be what the actual rule is, but just educating folks that those different rules are out there, and maybe changing some signage is one option that we could discuss as we move forward. Road sediment mitigation. There's a lot of dust. It's a dirt road. There's some obvious things that could be done with specific locations where the road comes up out of the canyon and goes up onto the flat of prairie. That is Pierce Creek. There's some specific things that we could talk about there. There's general winter road maintenance where they're plowing a dirt road in the winter. I'm not sure if there's any practices that are being done already or could be instituted to help out a little bit there. And one of those specific examples is Pierce Creek. So this is Pierce Creek pre-fire, and if you can't see my pointer, down on the lower end of that picture, you can see there's kind of a gully forming. This is 2011 pre-fire. That gully is pushing sediment out into the stream itself. This is 2015. And then it's hard to see with the shadows, but the 2018 aerial imagery kind of makes it look like the water's going underneath that pile of sediment, and there might be a fish barrier there. Even before the fires, this is a pre-2010 photo from a report in 2010. This is that debris fan that's down in Pierce Creek itself. So this was before the fire, like I said, so we've got a lot more sediment coming in. And an area where we could do something about it in theory, if that is physically possible, with a steep canyon system, try and get a road out of it. Irrigation system improvements. There are areas where there's a lot of canals out there that are open canals. If we were to pipe those or line the canals if they're already lined, we could save some water. Installing automation might be another option where we can save the farmer some time by being able to remotely operate or have it set to stay at a certain elevation instead of having to manually go out and change gauges or gates. And then self-cleaning screens to keep debris out, but also keep fish out of the canals. If any of the landowners that are here or the other ones in the basin would be interested in any of those things, we could go that direction with some of the funding that was just talked about. So, like I said, one of those examples is just there. If you have an unlined canal, there's a lot of seepage coming out of it. You pipe that, and you can save that 10 to 70% of flow that in some of these studies is showing is not making it to the end point. It's going into the groundwater and seeping out. We are looking at doing a recreation user survey, kind of two different ways of looking at that as how many people are actually using the basin and are they satisfied with what would they like to see out in the basin? So there's a range, and we could do a simple free Survey Monkey type thing. We can put flyers out, we can send emails to a lot of the contacts that we have in the room that also have their own distributions with the different NGOs and groups that are here. We can put flyers on the cars that the shuttle driver drives back and forth, and put QR codes and all that stuff, or we can go full bore and pay for somebody to do an official survey and send it out randomly. The last creel surveys that were done by Fish and Game that were the official full-on creel surveys were done back in the 70s, and that was around the time that the regulations were being changed and closer to when the dam was built than now. So I know Fish and Game was looking into doing creel surveys, and that could be part of the recreation user survey as we go forward. We could also do some sort of car counters or any other option of different things, and looking for input from others as we move forward on what data could be used in that type of scenario.
There was a car in the shade that you missed when you drew your.
I'm counting parking spaces and boats. That car is parked in front of the campsite.
So you weren't spying on the car?
No. So the car being parked in front of the campsite is one of those areas where there's overlapping use in certain areas that if you get multiple cars in front of the campsite, you might not be able to get the same number of boats going into that parking area. So these are just the general categories. I'm going to try to get out of this and give Kendra a second to talk about a few of the options that we have for research being done out of BSU that may be able to inform some of our decision-making going forward. And I'm not getting an email from
You can
you.
go through the software one, it's up on the stack.
Okay.
It's on there. While he's pulling that up, I know most of what's on those slides, and you guys have been looking at the slides for hours now. So, I'm Kendra Kaiser, I'm research faculty at Boise State, I'm a hydrologist there. And at Boise State, between myself and a handful of other faculty that I'll mention, we've been doing a lot of different work at the scale of the entire Upper Boise Basin. So none of our work is focused in on the South Fork Boise, but some of the data products that have already come out, some of the data that will be coming out in the future are certainly going to be relevant for the South Fork of the Boise. And then in addition to the watershed scale work that we're doing, some of the faculty are also doing field work that's focused on Morse Creek. So some of that will be relevant for the South Fork, some of it might not be.
I got it on that screen and I'm sharing it. It's not.
So I'll show you some pretty pictures and then we can drink coffee.
There it
Have
is.
lunch. Let's go to the next slide. I can take that.
That'll go to this computer.
So the first one that is going to come up is Lejo Flores. Lejo does really large scale regional climate modeling. So he has some climate reanalysis data for the entire lower portion of Idaho. Some of this data we have used in the Upper Boise Basin, both for historical analysis and then to feed into a bunch of hydrologic models. So these are really strong physically based models. Some of his students have used climate forecast and to consider how stream flow patterns coming out of the Boise River Basin are going to be changing into the future. So this top right figure came from Amy Steinke, who I believe is at IDWR now. And effectively, it's unsurprising under future climate, we anticipate stream flow coming out of the basin to occur earlier, higher peak flows. And his interests are around how the rain and snow transition is going to be changing into the future, which we most certainly will be seeing in the Upper Boise Basin, and then how we're going to be predicting and observing that change in precipitation phase into the future. So some of the modeling output that he is generating might be relevant for some of the work that Andy was talking about earlier, like what flows might look like in the future and how you can anticipate to manage in response to that. Next one. And then Anna Bergstrom is a biogeochemist, and she does a bunch of watershed hydrology and biogeochemistry in cold regions, and her students are also working in Morse Creek. She's also interested in shifting rain-snow transitions and then understanding which of those components is really making up precipitation. So this is a figure from data that they collected this past year, looking at how much of the stream flow is coming from rain versus snow. And so this is ongoing work. I can't really tell you much more details about it because it's not mine. And then the next one is HP Marshall. HP does some phenomenal snow research. He does both airborne snow remote sensing using LiDAR and radar. He does a bunch of ground-based instrumentation, and then he combines both of those things to do. Here on the right is showing some data from Morse Creek. They have been doing a ton of work in the Colorado River Basin in California to facilitate reservoir management. And some of the data that's coming out of those methods can really increase the accuracy of how we understand snow in the mountains. And some of the methods that he's working on right now are such that once you fly the radar one time, you start to really get a good understanding of the spatial variability of how snowpacks build up and melt out. And so they are also pushing forward some work in the basin there and flying LiDAR to get a better understanding of snowpack in Morse Creek. And then you can go to me. So some of the work that I have been doing, maybe. I'm a hydrologic modeler in a variety of ways. Earlier, Anthony mentioned the Prosper tool. So this is a figure of the Upper Boise Basin that came out of a paper that we produced, where we generated this probability of stream flow permanence for the entire Pacific Northwest. It was in conjunction with a really large USGS team. Some of the outcomes of this work are, one, having that data and model output available on StreamStats. And then our colleagues in the GS have also been working with Forest Service employees to get folks that are out in watersheds collecting more data, so we have a better prediction of this. So it's using Survey 123, and this is an opportunity where if there are folks that are already out in the watershed doing restoration activities, collecting other data, there are some really simple tools where folks can add additional data that will improve our predictions into the future. So with that project, that's really focused on no flow conditions, but myself and my postdoc are working on low flow conditions in ungauged basins. And a lot of that is focused on data harmonization and visualization. So who has stream flow data? Where is it? How can we get it all into the same place? How can we think about how to integrate data that's been collected by dozens of different peoples for dozens of different purposes? And then the other thing that I have been doing since being in Idaho has been focusing on stream flow forecasting and thinking about how we model the way that we manage the system. So you can go to the next slide. Some of this, this is an example from over in the Wood River Basin. And this is, I use this as an example because Trout Unlimited got funding to help start the water collaborative over there. Their Bureau of Rec Water Smart grant supported some initial research that I started doing over there around forecasting. And then from there, my colleagues and I were able to obtain even more funding from the USDA to produce, to take what we had done in the initial grant and then improve the stream flow forecasting models that we had developed. And then we're also generating an online interactive website where anyone in the basin can go and look at current stream flow and snowpack conditions and the current forecasting model outputs for the upcoming season. So that work is still in progress. The online data visualization tool will be launched in the springtime. And we've been working with the stakeholders from that water collaborative to make sure that the data that we're producing, the figures that are generated, are useful for the way they think about their system and useful for the questions that they have for the data. So this is more of just a general example of the types of things that I'm interested in, and how we can integrate a lot of these different data and modeling streams that might be useful for some of the other questions that are relevant for you guys. And then I have my emails on there at the beginning, so these slides will go out, and then if any of this is of interest, you can reach out to me or any of the other faculty that I mentioned. So thanks for a little bit of time.
All right, now is time for ideas on improving the watershed from you all. Does anybody on top of the list that we have just gone over have additional things? Okay. I know I've talked to a lot of you personally on the phone or over Teams or over coffee already, so
Well, I'll fill in a couple of items. One, to mention work with Boise National Forest and TU. In June, we were on the South Fork doing some eDNA sampling of the tributaries. So we'll have that information once it's processed. And the extended presence into the tributaries, just how far up we have detection of trout species. A contract that we also have with Water and Consulting to look at the culvert issues with Granite Creek and Rough Creek that was to be done this summer or fall. So we'll have that information to at least give us an idea. There are some passage issues and what the passage issues are with those two locations. So those are a couple of things in the works. The discussion, Anthony, you had on the road, from the South Fork going up to Prairie, was long ago, we had a, work done by Rocky Mountain Research Station on the amount of sediment coming off of that road. And it does affect Pierce Creek, like you showed in those illustrations, but also on the other side, there's a small catchment that puts sediment into a system where there's intermittent or storm flow that goes into the South Fork, and it also affects that section of the road from the boat ramp down to the Danskibble Ridge. It should be looked at to see if we can come up with some way to arrest the sedimentation that is affecting that road and the South Fork, because there's a delta that can build up in the South Fork that eventually gets washed down when the flow's going to 1600 or 1800. So those are a couple of things that come to my mind on what is going on or has happened. The discussion from earlier today that I would like to see some follow-up on with the University of Idaho is on active restoration of cottonwood and willow along the main river, as well as looking at reestablishing some of the side channels. And in some of my work with Trout Unlimited on a national grant committee, we work with some activity in the Green River and the U.S. Fish and Wildlife Service National Wildlife Refuge in Wyoming on the Seaskiddy River, where they are actively manipulating the openings to some of the side channels to reestablish water flows. And I think that would be an area we could follow up to learn more about how, you know, if the U.S. Fish and Wildlife Service is out there doing some active restoration of some of the side channel flows and things like that, maybe there's some lessons learned there that could apply on the South Fork.
Yeah, the TU project manager for the Seaskiddy, it's on the Green River, but it's the Seaskiddy Wildlife Management Area.
Yeah.
He is on, so I have not been able to talk to him yet, but that for the main river portion where we were talking about riparian work and connecting side channels, they're doing that on the Green River. So we will be able to have that type of information, and that leads greatly into how do we move forward from here. So we can go there unless there's anybody else that wants to think about or come up with some extra ideas on the types of things that we can do. Art?
I'd just be curious to hear from at least both of the landowners if they have any thoughts or ideas on what they've seen over the last, you know, multiple years. These guys are down there more than any of us, plus they're, you know, making their living off the land and stuff. And so I don't know if you've already had separate discussions with them or anything like that, to sort of get an idea of what they think is, you know, how that area has been impacted over the last, you know, especially with the recreation and everything else, and any conflicts or issues, opportunities that they see. So I just be curious since we're here. Is that fair to put you guys on the spot?
Well, you're it, but the only thing I'll say in the last 10 years is there's just so many more people coming to recreate that this river is not going to stay the same. And I don't know how we stop the people from coming. And if that's not going to happen, how do we mitigate it or make it so it's still multiple use? Because everybody loves fishing, everybody loves being out in the open. But like the bathroom issues and the parking issues, there's all kinds of issues.
What are the main entrances to access? I know of two off of Highway 20. How do
Yes.
people truly access?
Most people will come down, if they're gonna go just fish the river, they'll come down Cow Creek Road, which comes out in the middle-ish of the roaded section. There's people that drive over the dam itself and come down that way. Or you can come in Blacks Creek Road and through the town of Prairie-ish, and then down into the canyon that way. So there's three main access points.
Right. So capturing users at those entrance points might be something to think about, like a manual arm or gate where
Yeah,
there's a survey box and people are encouraged to fill out, like the Forest Service does. You're camping here, you're gonna hit this trail, sign in. And maybe there's a group or agency that collects those forms once a month or something at those entrance points. So there's some accountability at those. I mean, that might have to be a cooperative with landowners or whatever. But something that captures those users and makes them aware that they're entering a special place, you know. But, and then the other thing would be changing the quality of the dirt road, the river road. I don't want to say asphalt, but maybe some other dust-free, and that's a huge project, but impacting, changing the impact of that road since it's getting used so much.
Yeah.
Do we have anybody here from EPA by chance? EPA did, in I think 2022, they put out a paper, published a paper on environmentally sensitive mitigation measures for unpaved roads and to try to deal with stream issues, water quality issues, and sediment and dust. And it was I think it was based off of some work they had done with Pennsylvania DOT, so that may be an avenue. There are methods, people have looked at this stuff before without going to paving the roads, which proves to be a huge cost driver and an incredible maintenance issue as well, so.
Yeah, and road sediment is one of those issues that has already been brought up, and we will continue to have those conversations on how we can specifically address that. But at this point, I think we need to kind of transition to how do we want to work together to address those things. And there's, like I said, a range in formal and informal structures, agency driven or public driven, like we talked about earlier. I don't think that we need to be super formal about everything. I don't think we need a board of directors like Bren has. I'm not gonna dive too deeply into the different groups that are out there, but there is a range of groups that have similar types of funding from reclamation to put together these watershed groups, and they are all over the range of having a formal board of directors versus just having a group of people that get together, and everywhere from quarterly meetings all the way down to monthly meetings, subcommittees, all sorts of different things. And I think that we can work out how we want to structure things. I think the only real stipulation in the grant is that we at least have to have quarterly meetings of some kind. And they would like us to develop some sort of mission statement. So these are example mission statements. But I'd like to hear, and I'll put the Forest Service on the spot because I know that they're one of the agencies that I haven't worked with yet to talk about some of these details. Like, you're the land management agency down there. Everything is gonna have to go through you in some way, most likely. So do you guys have any thoughts on how involved you want to be, how much time you guys have, where if we come up with project ideas, or where do you want to be in that system? And how could you see this going forward with being the major land manager and landowner in the basin?
We're participants. I mean, we can take time and energy to do all these things, but we're participants in this group, just like everybody else are. You know, we have a lot of priorities on our forest, and we want to be able to do good things in the landscape, especially down here on the river, but there may be times where this isn't going to be our priority. And so if there's other participants and other partners that are helping us get work done on the ground, helping us with, you know, things out there, then it's more likely to have things getting done. But we want to do what the group, you know, we want to participate as much as we can in a group setting. We don't want to be driving this as much as participating.
Yeah, I'm not pushing you towards driving anything. I just understand that, like, if you have, someone's gonna be the environmental compliance, so it's either where we're getting the funding from or the landowner. And I think that might be potentially where we could have some holdups, is just the amount of compliance being done by all of the different funding sources that are out there.
Andy, if I could follow up on that, because I've worked a lot with Forest Service stuff. Let's just say, per se, we decided to do a boat ramp, some type of boat ramp there. It's on your level. What kind of time frame are we looking at to get, from we start till we get that approval for that?
It could be a while, because part of that boat ramp would be going through the clearances for ESA. And so that alone takes time. You know, the doing the NEPA and all of that coordination, it depends on what category it fits in and how much NEPA has to be done in order to make it fit. If it's a large scale project that could have some impact on, say, bull trout habitat, then it will take more time and have more investment.
And a public participation process involved in it.
Right, all of it has to have public participation, and so we get comments and we get, people that would be saying that this is an issue to them that we would then maybe have to analyze. So it all takes time, and I can't give you a specific, like, how many months, how many years, or anything like that, but because it all is different.
So one approach to this might be we need to have subgroups based on what the priorities that we've identified here, or that you've identified here, have subgroups that are targeting what type of activities, what types of projects are they putting forward. And then that gets brought back together to coordinate with a larger group to determine what type of potential impacts do we see happening, and what is the scale? Is it going to be a categorical exclusion where the stuff is so non-impacting that it can pretty much go forward without a lot of issue? Or are we going to have to do an environmental assessment or a full-blown EIS? And then there's enough people here that we should be able to figure out how much public outcry are you going to get by doing X, Y, or Z, and expect and plan for that whole process. But all of these have to be done within their respective groups, so you're not laying down the Forest Service to be bogged down in stuff that doesn't really affect you, or it may be more appropriate for Fish and Wildlife Service or the Endangered Species Act. So, there's subgroups to be determined by whatever the priorities are here in the affected agencies. If that makes sense.
And I will say, it's not that this isn't important, but the Boise National Forest is one of the priority landscapes that has been selected for the wildfire crisis strategy. And that is our priority, is the work and the capacity is on those areas that are designated in that landscape for wildfire risk reduction. It's not that this isn't important, but this would not be a forest priority.
Yeah, so if we can get either NEPA done through the funder and have you guys be like a cooperating agency, then any of these projects or types of things that we brought up, there's nothing you see as red flags or like, that's not something we want to do on the forest.
Right.
It's just the timing thing. Oh,
Yeah.
That's kind of what I was getting at.
I was gonna ask the ranger, is the fourth rack still active?
So the RAC is, because we are in that lapse in funding from Congress right now, that has not been renewed. So we are in a kind of a holding, there is a RAC, but it is not active right now because of the way that the Congress has not passed that bill again. So the farm bill and some of these other bills that are on hold because Congress hasn't acted to be able to pass the funding and pass some of these other bills again, that one is one of them.
Well, assuming that Congress gets their act together again.
Well played, sir.
Do you think that the Secure Schools and Roads Act that funded the RAC will be reestablished, or do you think that's dead?
I don't think it's dead. I think that there is some momentum still behind that type of project and those funding sources. I just don't know, as far as priority from Congress, where that would be.
It's something to put on down the road that we can at least consider as a source of funding, assuming that they reactivated a source of funding for some of these projects.
Well, I think that's
how we've been able to use it, your Pierce Creek Bridge and some other things we've been able to access and come to that.
Yeah, I think that's how we funded that Danskin boat ramp too, was through the RAC.
Kara, did you have something to say?
Oh, I just said, he had his hand raised, I just want to make sure you saw it, thanks.
Okay. So my biggest suggestion is to I can go back, get everybody on the distribution list that isn't already there, and kind of start subcommittees or some sort of smaller groups for the individual categories of things that have been identified in my conversations with a lot of you outside of today's meeting. Unless there is a series of unknowns or some educational presentations that could happen. So we could do a presentation on bull trout, or do a presentation on spawning, or do a presentation on roads, and get some more of those details if the larger group feels like we have a knowledge gap. But if we're okay moving forward with the general categories, at least that we have kind of lined out here, then maybe setting up some subcommittees to dive a little bit deeper, see what the actual feasibility is of some of these things. That would be my suggestion on moving forward from here, planning another large group gathering to get the information from those subcommittees back to the larger group, and then if we have any sort of competing or even complementary options to seek funding and do NEPA together, then we could use the larger group to be able to prioritize those things and see if we need to hold off for a little bit of time on any certain project because it's a lower priority thing, or if we're able to bundle stuff for compliance and funding opportunities. That makes sense to me. And then we don't have like the rafting community listening to road maintenance stuff and the other way around. That seem amenable to everybody? Did everyone get to sign in so I can make sure we update all of that stuff? Look at that, we got a minute to spare. Thank you all for coming. This has been a great turnout from everybody, and thank you for all your input and a lot of the hours that you guys spent talking to me before today so that this could run a little bit smoother.